Okay, let's go through the answers to the questions I set last lesson on distance time graphs. Here we've got a plot of the journey of a truck over time. Okay, distance is measured in meters up the side and time is in seconds along the bottom. Now, unusually, the scale here is equal spaces but not equal changes in the numbers. So we go 40 seconds, then 20, then 20, then 80, then 60, then 40. So this scale here is not uniform. So we have to be really careful when we're looking at the graph. So first thing, what is the total distance travelled by the truck? Well, we can work that out by looking at the graph and taking the final point, which is H, and oops, my red pen's not working very well, and reading off the height of that on the scale here in meters, which is 600. So the total distance travelled is the last point on the graph, and we read across and read off on this side. Determine the total time taken to reach the final destination. Now this one is slightly different because if we look at this graph here, the truck actually reaches its final destination, which is 600 meters, at point G, and it stays stationary from that period between G and H, which is 40 seconds. Now, to read off the time, we draw an arrow down and we read off on this scale, which is 260 seconds. Okay. 1.3 is a little bit more interesting. Which 2 points of the truck were travelling at the greatest speed? Now, if this was a uniform scale here, then we would look for the steepest line on the graph, which is DE in this case, that's the steepest, or possibly AB. Okay. However, this scale is not uniform, so we have to be really careful. So what I did, I looked at each one of these and I calculated the speed. And I did that by taking the distance travelled, 200, divided by 40, which gives us 5 meters per second. So AB is 5 meters per second. Okay, DE is travelling from 300 to 500, so that's 200 meters travelled in just 20 seconds. So that is 10 meters per second. So that is a much faster speed. So DE is the fastest speed, but I had to work it out using the formula speed equals distance divided by time. Okay. Between which two non-consecutive points did the truck change speed without stopping? So we can see here that we are moving at a constant speed, stationary, moving at a constant speed, and then moving at a different speed here, then stopping. So it will be between C, D, and D, E. This is where the truck is moving but changes speed. Okay. Calculate the average speed of the truck over the complete journey. Now, we work this one out by drawing a line from the first point to the last point. Okay, you'd use a ruler for that. And then we would work out and use this formula here. The speed, the average speed, is the distance travelled in total, which is 600, divided by the time, which is 300, which equals 2 meters per second. Okay, so 600 and 300 are the two numbers that we would get reading off the graph. We look at the average speed, which is from 0, which is point A, to up to here, H, and the average speed was 2 meters per second. Okay, Next one, 1.6, state one advantage of using an electric truck over the complete journey. And that the advantages are obviously less pollution because we're not burning fossil fuels. It will be less noise. So a cleaner environment, less pollution, less noise. Okay. Question 2 is about the International Space Station. And they give us some information here in table 1. So the orbital height of the Earth, above the Earth, speed of the space station, and time of one complete orbit. They ask us to calculate how many complete orbits the ISS will take in one day. So the first thing I'm going to do is look for some information. And it's this here that I'm going to use. Time of one complete orbit. So it takes 92.6 minutes to orbit the Earth once. Okay. Now, because that information is in minutes, I want to know how many minutes there are in a day. So let's work that out. One day is 24 hours. 24 hours, each hour is 60 minutes. So I'm going to multiply 24 by 60, which gives us 1,440 minutes in one day. Okay. Now, if the ISS takes 92.6 minutes to orbit the Earth, then in 1,440 minutes, or one day, it orbits the Earth, and we work this out by dividing 1440 by 92.6, which gives us 15.55 times. So the ISS will orbit the Earth 15.55 times every day. So it's moving pretty quick. Calculate the total distance the ISS will travel in one day. So let's look at the speed of the space station. So that is here. And the units are kilometers per second. Okay, because we're looking at seconds, I want to work out how many seconds there are in a day. Well, I know there's 1,440 minutes in a day because we've already worked that out above. And there are 60 seconds in every minute. So I'm going to multiply 1440 by 60, which gives us 86,400. If we multiply the 7.6 by 86,400, it gives us an answer of 656,640 kilometers. Now finally, question 3. We've got a distance time graph here, and we need to complete the sentences. So the answers are here. Between A and B, the student stops. So A and B, it's a horizontal line, so we know that the vehicle is not moving. Between B and C, the student moves at a constant speed. So B and C, it's diagonally upwards, so we know it's moving at a constant speed. C and D stops again because it's horizontal, and D and E moves at a constant speed again. Okay, the two we don't need is moves uphill and moves downhill because we don't know that information from the graph. All we know from the graph is how far the object has moved and how long it took. Okay,